Welcome to the course MCDM techniques using R. So, in previous lecture we started our discussion on TOPSIS. So, we talked about different details about TOPSIS. So, let us do a quick recap of what we discussed in the previous lecture. So, we talked about TOPSIS, what it stands for, technique of order preference similarity to the ideal solution. So, we talked about that typically only the criteria weights are to be specified by decision maker. Simple technique, easy to understand. Main idea is that the best solution is actually compared with the ideal and anti-ideal solution, and based on that idea we talked about 5 computation steps that are part of this method. So, one is performance scoring, then we do normalization, then weighting of those normalized score, then distance computation from ideal and anti-ideal points, and then finally computing the closeness ratio. So, these are 5 basic steps that we talked about. We also discussed each of these steps in more detail in the previous lecture. Then at the last part of the lecture we stopped at this point, where we were talking about this particular example exercise that we would like to do in our studio environment. So, this example is again on ranking of cars, just like we did in Electra. So, in this particular case we have 3 alternatives, 3 cars, you can see the names here, and then we have the 4 criteria. So, you can see the criteria as well, purchase price, economy, aesthetics and boot capacity. So, these are the 4 criteria which are to be considered. So, what we will do is let us open our studio. So, now for implementing TOPSIS model in our environment, we have 3 packages, and so we will go through each of these packages and understand how they what are the implementation, what are the function that they have implemented, and what is the kind of input that these functions take and the kind of output that is being generated. However, in terms of functionality there is not much difference, but still one, of course each of these interfaces are slightly different from each other. So, we will go through one by one. So, first package that we are going to cover is MCDA package. So, this package we had also used previously. So, you can see goal, ranking of cars, and we have 4 criteria and 3 alternatives. So, first we need to generate this performance matrix. So, this performance table, just like in the previous techniques, we had used the matrix function to to generate the this performance table. So, here you can see, since we have 3 alternatives and 4 criteria. So, you can see we have 12 values in this first argument in the matrix function, and these 12 values have been combined using this C function, combine function, and then the second argument is the number of rows, that is 3, then third argument is number of column, that is 4, and then by row, whether these values are to be arranged by row or by column. So, this particular aspect of matrix function we have talked about in previous lectures as well. Now, so let us execute this. So, let us run this code, and you can see here that a matrix has been generated. So, you can see for the column 1 the values are in the similar range, and this column 2 the values are in the same range for column 3, and similarly for column 4. So, because these columns are corresponding to the criteria, and the rows are corresponding to alternatives, right. So, let us also define the names of these rows and columns. So, name of rows are going to be based on the alternatives, that is name of cars in this case. So, let us run this, and then names of columns are going to be based on the criteria. So, we can see the purchase price, economy, aesthetics and boot capacity. These are the 4 criteria that we are considering. So, the name of columns are going to be based on this. Now, we have the named matrix, where each of the rows and each of the columns, they are named here, and the values are already there. Now, the second part is the criteria weights. So, this is something that is to be specified by the decision maker. So, here in this case you can see here we are going to we are going to create this weights variable for criteria weights, and we have 4 criteria. So, we need to specify 4 values. So, for the criterion 1, that is purchase price, we have 0.35. Then for criteria 2, that is economy, we have 0.25. Then aesthetics, we have 0.25, then boot capacity 0.15. So, given these values, you can clearly see here that the purchase price as a criteria, it is being given more weightage, and the boot capacity as a criterion, it is being given as the least weight, right. So, the decision maker, they would like to produce a ranking based on considering, based on giving higher weightage to purchase price, and then economy and aesthetics being given equivalent, but second highest weightage, and the last one is boot capacity. So, based on this, the decision maker would like to produce the rankings. So, let us run this code and create this variable, and names of these values you can see here. So, in the environment section also you can see that these 2 variables, performance table having the performance scores and the weights having the criteria weights, you can see have been defined. Now, another thing is the preference direction for each criterion. Just like other techniques, here also we need to specify this. So, criteria min max variable we are going to create, and since we have 4 criteria, so therefore for each of them we need to specify the direction. So, the first criteria, as you can see here, is the purchase price. So, purchase price is something that we would like to minimize, and therefore criteria min max variable, the first value is min, and then the second criterion is economy. So, this is something that we would like to maximize, and therefore this can value is max. The aesthetics we would like to maximize, third value is max. Boot capacity we would like to maximize, and therefore fourth value is max. So, preference direction is, this is how we can actually go about defining the preference direction. So, let us run this code, and then names of the. So, you can see we have recorded the preference direction with respect to each criteria. So, once this is done, then in this package MCDA, another thing that can be done is though we talked about in the previous lecture that the ideal alternative and anti ideal alternative are to be defined. We talked about 3 ways, and the third way was where the even these ideal and anti ideal point can be taken as input from a decision maker. So, this particular package provides this functionality. So, here you can actually define your ideal and anti ideal alternatives. So, this is one distinguishing feature of this particular package, and right. So, here you can see some values have been specified here. So, virtual ideal alternative. So, against so you can see here 4 values are there. So, given the 4 criterion that we have. So, with respect to each of the criterion we need to find out the alternative having the best value for the ideal alternative, and having the worst value for the anti ideal alternative. So, you can see the first value in the this variable positive ideal solution variable, you can see this is lower, and the first value in negative ideal solution here it is higher. So, this is because the first criterion was purchase price, which we are supposed to minimized as per the given preference direction. So, therefore, in the ideal the lowest value will take, and in the anti ideal the highest value will take. So, similarly, if we take the, if we look at the other values in the positive ideal solution, here other values they are on the lower side in comparison to what we have here in the negative ideal solution, right. So, let us generate these variables as well. So, we can always using this particular package we can always use decision makers input even for ideal and anti-ideal alternative. Now what we are going to do is we will do the TOPSIS modeling. So before we can use the functions of MCDA package we need to load this particular library into our environment. So let us run this. So MCDA is there. Now we can call this TOPSIS function. So more detail on TOPSIS function you can always go into the help section and find out. So in the help section you can always see here. So you can see the in the help section the TOPSIS function part of the MCDA package technique for order preference by similarity to ideal solution method, and you can look at the arguments you can see here. So we have performance table, then criteria weights, then criteria min max. So these three we have already defined. Then positive ideal solution, negative ideal solution also something that we have defined. Then the alternative IDs and the criteria IDs. So if you are interested in understanding what they mean by each of these arguments you can read this page and find out. So at this point two specific arguments I would like to talk about, alternative IDs and alternative IDs. So here this particular function gives us the flexibility to actually select the alternatives that we would like to consider. So out of the, let us say if there are 10 alternatives and for a particular model that we want to specify we would like to consider just the 5 alternatives. So this can be done using this particular argument. Similarly criteria IDs, so here also we can do some filtering. So if we have 10 criteria to be considered, if we want to consider just 5, so we can use this particular argument to actually do this. So in our exercise we will do something similar. So first model that we are going to build is based on just 3 arguments, that is performance table, weights and criteria max. So if you look at the help section only 3 arguments are mandatory, in the sense performance table, criteria weights and criteria min max are to be specified and other could be null, as you can see here in the help section. So therefore first model we are going to run is just using 3 arguments where we have the performance scores, the criteria weights and the preference direction for these criteria. So let us run this. So you can see these scores. So from these scores you can see the that second alternative is having the highest value 0.518 followed by the first alternative having value 0.481 and then the third alternative is having value 0.177. So we have got these scores and accordingly we can find out that second alternative seems to be the best one and we can produce a ranking as well. So this is one model that we can build, but because given the functionality that is provided in this package and in this function we can specify some other models as well. So for example in the second model we are going to in the second model we are going to consider the decision makers input for ideal and anti-ideal points. So you can see we have also specified the positive ideal solution and negative ideal solution, the 2 variables that we had that we had created. So we are passing these 2 variables as well. Now these ideal and anti-ideal points which are being specified through this function, through this call to function, they are going to be used to perform the TOPSIS model. So let us see whether the results will change or not. So let us run this and you see the same results because the actual the values that were actually the way we had defined these 2 points, ideal and anti-ideal points, were actually using the same values which are part of which are actually internally generated within the function if we do not provide the these 2 variables. So the same values were used, therefore we are getting the same result here. However you can always specify some other values based on the decision makers subjective preferences and therefore you will see that results will also change. So, so this is the second way of specifying model and running it. Now in the third way, now in this third specification the results will change, we will see this. So here instead of instead of 4 criteria we are going to consider just 3, and instead of 3 alternatives we are going to consider just 2 alternatives. So the arguments that we are going to pass here is the first 3 arguments: performance table, weights and criteria min max, and right. So so model 3 is we will consider 2 alternatives and 3 criteria. So these 2 alternatives have been considered, and these 3 criteria have been considered. So you can see boot space has been has not been considered, and third alternative has not been considered. So we run this model. So this is what we get. So you see once we remove one alternative, so third alternative has been removed, this one the Fiesta car. So this was the value in the previous model, and now you see since we have just 2 alternatives the numbers have slightly changed. So now the first alternative score of first alternative is quite close to what we have for the second alternative, but still second alternative remains best even after removing third alternative. So for this particular specification we can see in terms of ordering we are getting the same same ordering or same rank, right. Now in the fourth model we will consider just 2 alternatives and 3 criteria now, but this time using the decision makers input, right. Now the earlier model that we had built, there these ideal and anti-ideal points were based on the same values were taken which are actually generated as part of the function if we do not specify anti-ideal and ideal points. Now because one alternative and one criterion has been removed, now the same input that we had used previously, if we use the same input again, now the results will change, right. So let us run this, and you can see here the previous model the values were 0.494 and 0.505. However, in this model the values have changed, 0.5181 and 0.5146. If you look at this, first alternative has become the best alternative, and the second alternative has become the second, right. So because this time we have used the decision makers input, so the results are changing. In the previous model we had not used the decision makers input for ideal and anti-ideal points. So those ideal and anti-ideal points were generated internally within the function as per the underlying coding of that function, and therefore the results were different. So this particular package and function has a lot of functionality to actually specify different types of TOPSIS model. Now what we are going to do is we will look at another package which is offering us some other functionality. So we will see about that. So name of this package is MCDM package, right. So the example remains same. So we have the same goal, ranking of cars, we have the same number of criteria and same criteria actually 4 criteria are there: purchase price, economy, aesthetics, boot capacity. We have 3 alternatives as you can see here. So we are tackling the same problem, same decision problem. The performance matrix is also same, right. Performance scores are same and all these details remain same, weights are same, preference direction is also same. Now TOPSIS modeling here, now we will have to load this library, this package MCDM. So let us run this. So it seems this package is not installed. So let me first install this particular package. So once this is done we will use the functions of it. So just like in previous lecture, this is the command that we can use, install.packages, and the name of the package is MCDM. So within double quotes we can enter this, and this would be installed. So, in this particular package we actually have two functions to perform TOPSIS modeling. So, we will specify models using each of those functions. So, let us do that. So, let us first this installation is complete. So, let us first load this library. This is done. Now, first function that we are going to use is TOPSIS linear. So, and the second function that is available is TOPSIS vector. So, these two TOPSIS functions are different in terms of the normalization procedure that is inbuilt in the coding of these functions. So, TOPSIS linear is having a normalization procedure which is similar to what we talked about the ideal normalization in the previous lecture, and the TOPSIS vector this particular function has a normalization procedure which is similar to what we talked in distributive normalization. However, the actual details are slightly different, but in terms of understanding they are similar. So, TOPSIS linear, the normalization procedure is similar to ideal, and TOPSIS vector normalization procedure is similar to what we discussed in distributive. So, let us we are going to specify two models for each of these functions. So, first one is TOPSIS linear, and we are going to specify these three arguments are available with us. If you compare with the previous package, that is MCDA package. So, we had more number of arguments, a bit more functionality to specify different kinds of model. However, in this case we can just specify the basic variable, that is performance scores, the weights of the criteria and the preference direction, and everything else is computed as per the functionality coded into these two functions. So, let us run this. So, you can see here this is the score that we get. If you look at this number and right, and you look at the numbers that we have got using previous previous package. See, so this is what we had got using the previous package, right, and if you look at the numbers that we have got now, right. So, the previous package numbers and this one, right. So, in this second car was found to be the best one, and then now what we have is it is actually the first car which has been found. So, we changed the normalization procedure and the results have changed. Now, the first car is having the highest value and this is considered to be, now this is coming out to be the best car here. However, in the previous package it was different. This is mainly because so in the previous package the normalization procedure was actually different. It was similar to similar to the distributive normalization that we had. So, let us now see if we use the second function which is actually using the distributive kind of normalization, whether the ranking comes out to be same like the previous package. So, the name of the function is TOPSIS vector, as you can see here. So, what we will do, we will run this and you can see the results are different. So, here again second car comes out to be the best car and the first car comes out to be the second car. Now, if you compare these numbers to what we had in the previous package, so these numbers are same, right. So, in the previous package, that is MCDA package, probably they were also using the distributive normalization procedure. Here TOPSIS vector is using a similar kind of normalization procedure. However, TOPSIS linear is different and you can see the results also comes out to be different. So, depending on the changes, the way we specify our model, few things that we change here and there, the rankings might actually change. So, that has been one of the limitation or critique of MCDM techniques in general. So, now this is the second package that is available in our studio, in our environment. Now, we will talk about the third package that is available. So, name of this package is TOPSIS, and again we are going to use the same example, ranking of cars. We have 4 criteria, same 4 criteria: purchase price, economy, aesthetics, boot capacity, and same 3 alternatives, 3 cars that are to be ranked. We have the same performance table again, and then the other details are same, criteria weights they are same. Now, preference direction in this particular package are specified differently. So, in previous 2 packages we specify using these character values max min. However, in this case we use minus plus these the characters minus and plus. So, if it is to be criterion is to be minimized, then we use minus, if it is to be maximized, then we use plus. So, therefore, you would see that our variable criterion min max, now this is changed slightly. So, we will run this again. Now, to be able to run this model using this particular package, we need to have this TOPSIS package installed. So, what we will do, I think probably this package is not installed in this particular system. So, we again will use the same command, same function, install dot packages, and we will install this within double quotes. We have to specify TOPSIS, and let us install this package. So, this is done. Now, we will load this package so that we are able to use the functions which are part of this one. So, let us run this. Now, the function that is available in this package is named TOPSIS in small letters. So, more details on this particular package you can always go into the help section, and you can find more details also. Similarly, for the other package MCDM package, the TOPSIS linear and TOPSIS vector function, for them also for more details you can always refer to the help section. Now, here we are going to specify just one model, and this function has just 3 basic parameters. So, performance table weights and criteria min max we have already specified. So, if we run this line of code, then you can see the scores, and if we if you want to compare the scores that we have just got, you can see the second car, the second alternative second car comes out to be the best car, and the scores are similar to what we got in the previous 2 packages as well in some of the models. So, here also distributive mode of normalization is used, and so we just look at the 3 packages that we have covered, the MCDM, MCDA, and this TOPSIS package. So, the MCDM package gives us 2 ways to normalize, so that is different. However, the MCDA package gives us flexibility in terms of specifying the ideal and anti-ideal points, and also in terms of filtering the alternatives that we would like to consider for a specific model, or the criteria that we would like to consider for a specific model. However, this TOPSIS package is this particular package provides the least functionality out of 3 packages that we have. So, probably you would like to prefer MCDA and MCDM packages for your TOPSIS modeling. So, let us go back to our discussion. So, now through R we have understood how different steps of TOPSIS can actually be implemented, and the modeling TOPSIS modeling can actually be done. Now, let us move forward and we will discuss few more points on TOPSIS. So, it has been observed that sometimes TOPSIS provides illogical results, in the sense because the main idea as we talked about is comparison of the alternatives from the ideal and anti-ideal points, and it might so happen that given the data that you might have, that sometimes some extreme point might be picked up as the best solution by the TOPSIS modeling, and there might be a superior compromise alternative that might be available there, so that might not get picked. So, sometimes you would feel that it is giving illogical results, and extreme alternatives they are getting preferred over a superior compromise alternative. Then the second second point about TOPSIS is the use of Euclidean distance matrix. So, the way Euclidean distance matrix is defined mathematically, the way it is done, the way computations are done, it typically magnifies large distances. So, so the in a way the values which are in a way particular scores which are having higher values, they will in a way dominate the overall computation and therefore overall results. So, this has been one limitation of Euclidean distance matrix. That is why if you compare the results that you get using the Euclidean distance matrix and compare the results that you might get otherwise using the Manhattan distance matrix, so the results might be different. So, this is another limitation. Now, as I have talked about that TOPSIS, this particular method is referred to as a distance based method as well. Because of the distance based matrix that we used, and distance based computation being the main core of the way alternatives are ranked. Similarly, it is also referred as a reference based approach, because these alternatives are actually being compared with respect to an ideal or anti-ideal scenario. So, in that sense this method is also called as a reference based approach. Right. So, with this we would like to stop our discussion on TOPSIS, and in the next lecture we will start with another technique. Thank you.